Hurlbut from basically an independent software security consultant off the East Coast, Connecticut, and look forward to him talking about threat modeling and secure software design. So, let's get started. Thank you.
Okay. Okay, well, thanks, everyone. So, yeah, today we're going to talk about threat modeling, which is actually one of my passions. In particular, what I do is, as was mentioned there, I'm an independent software security consultant. I'm an architect. I'm a trainer. I've been doing development of some sort for now almost 30 years, which is crazy because thinking back right out of high school and so forth to do a lot of this stuff. Development, architecture, project management, leading developers, mentoring developers, all that kind of stuff. About 12 years ago, I started looking more and more at security. Now, that was a time when it wasn't as popular. It wasn't seen as much. You don't talk about it as much. But what I found was that we need to think about it. We need to talk about it. And so, as I've gone along, one of the things I also learned way back when was how to do threat modeling. And then again, that was a thing that just Microsoft and others were talking about. And the last few years, it seems like it's coming back into play again. Because I didn't hear about it for a while, but now it's starting to come back into play. And just out of curiosity, whatever comes from the client directly into your database, right? That's how you fix it. But it's still a design issue. It's still something built in, and it's still in there today. You have to be aware of it and understand your tools and understand how do I build around that in a secure way. Another issue that's come up in the news we've seen is the Jeep Cherokee hack. Everybody heard about that one? Right? You know, they say that, 3 out of 4 Americans have now forgotten about this, but 4 out of 4 car makers certainly have not, right? This is still a big deal. And we still hear about it sometimes in the news, too, about different issues with cars and now, you know, being the fact that they're all software. What happened here was last year, if you remember, Chris Valasek and Charlie Miller presented at Black Hat where they were able to find a flaw in the design where it's Jeep Cherokee in the entertainment system that you could subscribe to that allowed you to be able to, let's say, watch movies in the system. It turned out that you also not only had access to the internet and maybe pull things down, but you also had an IP address. And so what was you were able to do is somebody could come in, find you through that IP address, make your way through the entertainment system into the rest of the car and take over certain operations. Now, you say, well, you know, like the window washers and wipers, rather, and so forth. But you could also take control of the brakes. You can take control of the car in terms of moving it, and that's what they did in their demo, which was, you know, an amazing thing. So, again, a design flaw. Who had the idea that it was okay to make this available so that somebody can take over a bus that perhaps could do harm to people? Another one, not software specifically, it's more of a system design, but the Target breach was something also in the news in the last few years. Again, a design flaw, design issue where we had network access given to a third-party company. In this particular case, it was an HVAC company, being able to come in directly, you know, to the system, to the network, no segmentation involved. And so by attackers going through the HVAC and basically having full access to everything, of course, they also had full access to the point-of-sale systems, and, you know, there's some issues there and so on and so on. I mean, we can talk all day about this. But again, a design issue, in this case, a system design issue. So this is where it matters. Thinking through these things matters. And where you make those decisions, where you make choices about how you build out systems really matters. And so talking about that, well, how do we solve that? And that's what we're going to talk about today, is essentially taking a look at threat modeling and how it can help you with secure software design in particular. So what is threat modeling? Well, to me, it's something we already do in our personal lives. When we lock the doors to our house, when we lock the windows, and when we lock the doors to our car, we're already thinking ahead about what could go wrong. We're essentially, we don't leave those things open because, why? Well, more than likely or possibly somebody's going to come in to my home, take something. If I leave things in my car just out in the open, somebody will come by and see it. Or if I leave my door unlocked or window open, somebody might take it. So we're already thinking about these things in our personal lives. We may not realize it. We may not necessarily put a name to it. But it is a kind of threat modeling in the sense that we're thinking about what could go wrong. We weigh the risks and act accordingly. Well, actually, what we want to do is try to apply some of those same thoughts to how we design software and how we design systems. We want to think about and think ahead. What could happen here? I think the number one question I hear, and one of the things that I do in my own work in consulting is I help customers think about these things. And in particular, one of the questions that I hear often is, when we talk about user interaction and so forth, is, well, why would a user do that? You ever heard that before? Why would anyone do that? But that's the point. They would, and they may. And so then you have to think about it. So just talk really quickly about what are things that threat modeling can help you do. To me, it helps you bridge some gaps. For example, between the builders, the breakers, and the defenders. It helps the builders focus on the security features, the developers, the people who are putting together secure systems. It helps the breakers know where the critical attack surfaces are. So the people that are doing the pen testing, the penetration testing, it can help them understand, they don't have unlimited time, but if they spend some time to think about the design, to think about the actual threats to the system, it could help them in locating or localizing their attacks for breaking into the system. And the defenders, it also helps them understand the patterns. What is it that attackers may be looking at our system? Understanding the threat model of the system can help you do that as well. And I think it's in many ways it helps security and business understand each other, because threat modeling is actually ultimately a business decision as well. What are the threats and how does that impact my business and how I build my system? So where does it fit? It's one of the security tools. We already know about these: penetration testing, fuzzing, all those. A lot of automated tools. Threat modeling, on the other hand, is really a process. It's a way of thinking. And if you've been in security for a while, again, we talked about some things we already think about. You don't go anywhere probably anymore and see things the same way, right? Once you start thinking about security, you see an open door, you say, well, what if somebody came in that way? Or I see an open port on a device, and you think, what if somebody decided to plug into that and see what's happening with the protocol that's coming across? So it's a way of thinking. And ultimately, as we'll take a look at, it's a tool that's useful for secure design. So here's the official, unofficial definition. It's a process of understanding your system and the potential threats against your system. And I like to think of, when I'm creating a threat model, I want to have these particular elements as a part of it. So an understanding or a diagram of my system. What is it I'm building? What is it that we're trying to build here in our system, whether it be software or an infrastructure? Any of the identified threats, what are people wanting to do or could do in the system? And any mitigations. So as we go through, what we'll find is requirements. We'll say, okay, we have a threat here. Has anybody done anything about this? How do we counter it? So those are your mitigations. And then priorities by risk. And I think this is really important, because sometimes if you find all kinds of problems in your system, for example, people will chase vulnerabilities like crazy. I've got 520 vulnerabilities. Okay, what are you going to do with that? You can't fix them all at one time. And so threat modeling, another aspect of threat modeling is risk management, where you're trying to understand, okay, now I know this about my system, let's prioritize it, figure out what's the most critical thing, and fix it accordingly by priority. So those are things that I think essentially come together with the threat model. A couple of quotes I have. This is from Michael Howard at Microsoft. He wrote Secure Code 2. Dev team with awesome, complete, accurate threat model gets my admiration and not much of my time because essentially they don't need it. And I found that as well in myself, in my own experience, that companies who are starting out with threat modeling, thinking about that in their design, thinking about that in their requirements, are already ahead of the game. Another quote by Brooks Schoenfield. He wrote a great book that came out last summer on threat modeling and on secure architecture. As I practice it, threat modeling cannot be the province of a tech elite, but instead it's best owned by all the development team. And what I take from that, and I like that idea as well, is it's not just the security people that you want to be threat modeling. You don't want to just say, okay, you go do the threat modeling and come back with what you find. But instead, my approach, and Brooke as well, is that we want to try to get everybody involved and everybody thinking about threat modeling, and everybody can contribute to the design of systems. So talk about some definitions. A threat agent is essentially someone or a process that wants to do harm to your system. So that can be an attacker. It could be, again, a process that is running on your system. The threat is the goal. It's what the adversary wants to do. For example, a threat may be that an adversary wants to take your credit card information. That's the threat. How would they do it? Well, it turns out the way they would do it is typically through a vulnerability, and there's a distinction between these two. A vulnerability is the flaw in the system that helps the threat agent realize the threat. So, for example, if I have a website and I perhaps have a SQL injection vulnerability, well, because of the presence of the vulnerability, the SQL injection, an attacker could then realize the threat of obtaining all my credit card information, or changing my database, or dropping my database, or tables, and so on and so on and so on. But without the vulnerability, without the SQL injection being there, then really I don't have that threat. So there is a distinction. Some people try to use them interchangeably, but they're not the same. At least I don't see them the same, and many others do not as well. There is a distinction. So the vulnerability helps make the threat realized. But understand that the threat itself is something that could happen as a result of the vulnerability being there. The attack is essentially the threat agent taking advantage of that vulnerability. And there are a couple things here that I'd like to point out. Usually it is related to a motivated and sufficiently skilled threat agent. So motivations can change or vary depending on who's doing this. So, for example, years ago there used to be what were called script kiddies. So usually like teenagers would say, hey, I got some kind of script. I'm going to throw it at this website, see what happens. Do I know what it does? Absolutely not. I don't care. It's just fun. I want to deface it or something. And all the way up to a motivation of a criminal, of a state-sponsored attack where they want to ultimately, typically, is money, personal information, other kinds of things in order to ultimately obtain money. That's typically what these state attackers are doing, or subvert nation states. Sufficiently skilled, I already talked about the script kiddie, who may not know what he's doing, all the way up to the nation state attacker, who is absolutely skilled. And I don't know if you've seen it, but there are criminal organizations that basically have a DevOps, and they have check-ins, and they have project managers, and they have all that kind of stuff, just like in your own organizations, mainly because it is it's something that they are serious about and they need to spend time on and focus on. So you have all kinds of these people, but ultimately various motivations, various skills, the threat agent taking advantage of that vulnerability produces the attack. Assets, something of value. It could be your credit card information. It could be other kinds of things. It varies. But the key is, and I know in some, for example, the FAIR approach will say an asset is anything that you'll lose money on. Basically, it's a loss of some sort. This is a threat modeling vocabulary. This is a nice graphic by John Stephen at Cigital. And these slides will be available afterward if you want to follow my Twitter. Follow my Twitter. I'll post a link to it. But this is where he's relating all the threats, the attacks, and the risk, and everything, and how they work together. All those terms. So that's a really nice slide, a visual. Talking about approaches to threat modeling, there are many different ways to do this. My particular approach is typically software-centric, and that's what we're talking about today. That's where I focus on secure design. I look at data flow diagrams. Another one is more asset-centric, where you may use attack trees, essentially workflows through your system. So, for example, if I've got a website and I want to be able to exploit an XSS vulnerability, what are the ways that I may be able to use XSS in order to do something? For example, the threat may be I want to grab your session cookie. And how do I do that? So that may be an attack flow that you might go through. And then you would, at each point, determine that you have the right mitigation in place to prevent that. So that's one way to do that. Another is attacker-centric, and that was what I was talking about a moment ago, where you're focusing on the profile, you're focusing on the various patterns. So, for example, as I mentioned, a script kiddie will do one thing very different than a nation-state hacker, perhaps in attacking your system. The bottom two there, a lot of times will apply more to network or infrastructure. But the way I see it is, when you're doing threat modeling, a lot of these things you can think about depending on your system and what makes sense. So when do you do threat modeling? Well, ideally, it's first. You do it first. So typically, you should come in the requirements and design phase. So I have there in this diagram threat modeling as part of your design. It can also become part of your requirements. And actually, threat modeling will also uncover new requirements. As you go through the process, you will typically find, oh, there's something else we're missing. We need to put that in place. If you're following a more of an agile methodology, you can make it a part of your sprint. So there you can see where in the story, you're building out your story, you define what's our threat model. Or as you're iterating through, various sprints, you might, put in there and say, okay, here's a new feature. What's our threat model that's associated with it? So along with that, you can come up with user stories and attacker stories as well. So if you never did threat modeling, and I remember earlier I asked you if you've done threat modeling or you are currently doing threat modeling, the reality is it's not too late to start, for the most part. Just realize that it'll be more difficult to change major design decisions later. I mean, if you've already, picked, let's say, if you pick some framework that is inherently not secure, and then decide, okay, now we need to be secure, then revamping the entire thing is going to be a lot of effort. So you want to do these things ideally up front and early, but I'd say do it anyway. Go through the process. Go through the stages of trying to figure out where are you in your system. How secure are you? Still do it. So let's talk about a typical threat modeling session. And what I describe what I'm talking about is, let's say that you've never done threat modeling before. You're looking at your system. You want to go through and try to figure out, where are we? Here are some things that I've found to be very useful to get started. So first thing is you want to gather documentation. Who built this system? When was it built? What was the purpose? Why did we do what we did? And that could also apply to some new things, but especially for things that are existing. Gather your team. Again, don't make this one person's job. Have lots of people involved if you can. Developers, QA, architects, project managers, stakeholders, people who have an investment into this system in making it secure or making it productive, making it generate revenue. I mean, those people count because all of this stuff ultimately can affect your bottom line. Understand the business goals and the technical goals. And sometimes, they may not necessarily match what your security goals are. For example, I worked with a client where we talked about putting two-factor authentication in place. And their goal was, yes, we want to do that, but not for everybody. We have some users we don't, and some administrators we do, for now. And my recommendation was, well, we need to do it across the board. And I said, no, that's not our goal right now. So you have to be aware of what your goals are and why you do what you do. The other thing about this is also understanding your technical goals. For example, why did you choose Java as your framework? Why did you choose .NET? Why did you choose that open source library? Why did you, those are important things because all of those things can impact the security design of your system based on those things that you chose. Meeting dates and times, agree on those. And then I like to say, plan at least a 1 to 2 hours focused session. Don't make this a whole day thing. And the reason is because ultimately it becomes almost a code review. And it's not a code review. We're not talking about looking at your code and getting that far down. We're talking more of a high-level view about the architecture and the various data flows and things like that. So make it very focused on understanding what are the security issues in the system. And then most important, and this I've learned through trial and error, working with teams, is be honest, leave ego at the door, and no blaming. It's so easy to, when you're looking at security, and especially in a system that's already been built, and you're missing things, is to say, oh, why didn't we do that? Who didn't do this? Oh. And then to find out, as an architect, well, I know we set up our authentication process this way, and the developer comes back and says, well, actually, no, we didn't. We, took a different path that day because it wasn't too difficult or whatever. And you find out those things. The key is, this is discovery. It's understanding. So try to leave those things aside. Again, be honest, leave ego at the door, no blaming. Some simple tools that you can use, a whiteboard, just to draw your application, your system. You can use Visio for the diagramming, Word or Excel to document. One thing I like is Dennis Cruz's simple threat model, one-page template and concepts. He's been working on this a little while. That's a link to it, but essentially it looks like this, at least the latest, I think about a month ago or so I pulled this off his site. But essentially it's a page where he's trying to keep track of your diagram, various entry points, assets, and threats, in this case based on Stride, just to keep track of what is it in your system. On the back, he has these concepts. So, what is Stride? What, the vocabulary and so on. So that's something that he puts together. I think it's pretty cool. What I like to use is this worksheet, which is just keeping track of the risk level, the threats, description, countermeasures, and so on. And then, of course, the follow-up, which we'll talk about later as well. So simple tools. Keep it simple. There are some other tools out there, but don't look at these until you understand the process, because if you jump into these, as I said, there's no automated tool out there at all. You can't just say, point to my system and build one. It doesn't work that way. You have to think through, okay, how is this built? What are things that are moving between the various pieces? And then the potential security issues that might be represented. Once you understand the process, then some of these tools may come in handy. Lately, I've been evaluating Threat Modeler. It's a very interesting web-based collaborative tool from My App Security. Take a look at that one. The free one from Microsoft is pretty good, but it has some limitations. It's a free tool, but in terms of upgrades and so forth, not sure. And then there are a few other options there as well, but and I'm sure there's some others out there. But the key is be familiar with the process first. Start simple, because it is a thinking tool first and foremost. So as you start to get into doing the threat modeling session itself, one of the things I like to do is review security principles, the basic security principles. For example, securing the weakest link, defend in depth, failing security, economize mechanisms, simply keep it simple. Least privilege, not sharing mechanisms. For example, don't make authentication be your authorization too. Don't make authorization work like your authentication. That's very key. Be reluctant to trust. Promote privacy, security usable. We talked about that earlier. So there's a lot of things that we go over or would go over. One great document to take a look at, if you haven't already, is this one from the EEE Computer Society Center for Secure Design. They wrote this a couple of years ago. A bunch of companies got together and wrote these top 10 software security design flaws. And essentially what they were trying to talk about is, what is the difference between a bug and a flaw? And a bug is essentially an implementation level software problem. Someone forgot something, someone missed something, or they mistyped something, and now you have a bug in the system. Very different than a flaw. A flaw, on the other hand, is where we've made a mistake in the way we've made a decision. So, for example, a bug is that I didn't put the right number of characters in a password. Let's say the flaw is I've made the wrong decision about how I'm storing that password. For example, SHA-1. Don't use SHA-1. That's a design decision that you've made that now is a flaw that perhaps could be exploited. So that's very key. Out of that document, you'll find there's 10 different things that they have described as flaws. Cryptography comes up all the time. They always say don't roll your own. That's obviously a big flaw. But for example, one of the things is, neglecting to authorize after authentication. Some people say, well, I've authenticated, and then we move forward without doing the access control. So some very key things. And then, of course, the recommendations are just the opposite of that. Earn or give but never assume trust. Always use cryptography correctly, and so on and so on. So these are things that you want to review with your team and make sure everybody understands the difference between what's a bug and what's a flaw. Now that everybody has that basic foundation, then let's talk about the actual threat modeling process itself. So this is what I've come up with, and others have come up with maybe 5, 6 of these, 7 of these. I've tried to pull it down into 4, and even in this, there's some stuff that comes out of this, but I'm trying to make it as simple as possible. First thing is draw your picture, understand your system and the data flows that go between your parts of your system. Identify the threats, determine the mitigations and risks, and finally, which I think is one of the most important things, is the follow-through. Don't just make it an exercise that, hey, we did it, great, let's move on, but something that you continue to revisit. So drawing your picture, let me just ask you, anybody have an idea what that is? Make a guess. Anybody? It's a web app. It's a web app. And you've probably seen this before, right? 3-tier web app. Oh, we got a browser, we got a web server, we got a database server. But when you look at this, just drawing this out, you don't really know a whole lot about it, right? You don't know exactly what's going on. You especially don't know what's going on inside the web server. So this is a start, but it's not enough. What you want to do is you want to get a little further into the processes that are happening inside that web server. And so a good way to do that is to use, and this is an example, of using data flow diagrams. Now you can draw pretty much anything in any nomenclature you want. This is just a recommendation, or a lot of people do this in threat modeling. But to represent these various parts of your system, the entities, the processes, the data stores, and trust boundaries. Trust boundaries is kind of an interesting thing because that's where you're going from, okay, I'm not authenticated and now I am, or I'm not authorized and now I am. And that can be really key about, well, what do those mean in my system, essentially? So what we're wanting to do is understand the logical and the component architecture of our system and the communication flow and valuable data moved and stored. And the reason why we do that is it turns out that when data is moving back and forth, let's say I have two things that never talk to each other. Not so interesting. If the database is over here by itself and nothing ever touches it, ever, it's not very interesting. But when the data starts flowing, whether it's a network connection of some sort, pulling back the data, storing the data, it turns out that connection, how the data is moving back and forth or between components and then getting to the database and so on, is much more interesting to an attacker because that's where you particularly could be most vulnerable. And so that's why we want to know, how is the data moving, where is it moving to, and how is it being authenticated and authorized and so on. So for an example, just to start off with, we might look here at building out, okay, users and admin, hitting a server. 2 entities or 2 users, and the kinds of data they're sending back and forth, requests, responses. Perhaps the admin is setting up some things on the server, and the admin is reading in logging data. And there's a boundary between those users and the server where outside I don't have the right authentication authorization, and inside my request is now authorized. It can do what it needs to do. Going a little further into the system, that would be what I would call a level 1 diagram. This is more like a level 1. Level 0. This is level 1, where I'm defining a few more things in my system. So here I'm again documenting the data flows. I have the users and the admin again. I have the web app, and I have some services, authentication service, audit service. I have some files, data files, credentials. I also have this management tool. And then I want to define some kind of trust boundary where the users are able to go from, let's say, from outside inside, and or maybe around that user, and everything around that user is either not trusted and now trusted. So you define some of those things, and as you do that, you're wanting to document what you find. And so, what are my users, my the entities that I determine, my processes, the various services, the data stores, the data flows, how does data flow? And so what I would typically do is try to have a diagram that matches, what my system looks like at a high level view, and then try to understand, okay, what comes here? What are we using here? And ask some questions. So for example, in the request to the web app, what are we using? Are we using HTTPS? Are we using HTTPS inside the system anywhere? I see a lot of companies that don't do that. They do a very good job of hardening the outside, but on the inside, it's that candy bar, the crunchy outside and the chewy inside. Ever seen that before? Yeah. So those are good questions to ask. What are we doing when we're sending those requests? How are we authenticating? What kind of mechanism, what kind of protocol are we using? So those are questions that you would ask about your system from a security perspective of how this is working. So once you've done that and go through that exercise, you now have a diagram and understanding of your system. So let's talk about identifying the threats, which of course, as you can imagine in threat modeling, that's the most important part. What we're doing there, there's a few ways. You can use attack trees. We already talked about that. You can use some libraries that kind of help you think about the kinds of attacks that are well known, CAPEC, OWASP Top 10. You can use checklists. OWASP has a couple of really good ones, ASVS and the proactive controls, where basically they say, okay, here are the things that we know, or questions that you can ask your system. Have we done this? Have we done that? And so on. You can use use cases or misuse cases. Those are great because so many times when we build systems, we think about, well, how does this work from a use case, the workflow, but we don't always think about the misuse case. And again, remember I asked that question, why would a user ever do that? Well, that's a misuse case. And so it's good to think about those. There's a couple games out there that kind of help you through those things. This is from OWASP, this cornucopia game, where they have various areas, authorization, session management, and so on, where you basically play a round, and let's say I've got 2 of cryptography, and you have something to read, say, well, does this apply to my system? Yes or no? And at the bottom of the card, it will tell you, well, this is found in OWASP Top 10, this is found in CAPEC, this is found in whatever. And so it's a way of helping your team understand about threats. It's a way of understanding about some of the types of things that are out there in a system. Another way to think about threats or to find threats, and this is probably the most well-known for threat modeling, is to use STRIDE. STRIDE is, and it's essentially, it's not categories, it's a mnemonic. So they're not a bunch of spoofing type. It's basically helping you understand, well, here's a kind of a way of threat in your system. Spoofing is, pretending to be who you're not. Tampering is changing the data. Repudiation is saying, hey, I did something, or you can't prove that I did something. Information disclosure, making some sensitive data available. Denial of service, of course, means I can't use your application or your service. And elevation of privilege, the most dangerous, where basically if I'm a user and I have the ability to get into your system and subvert it without authorizing properly or access control, I can be an admin without having to go through the process of being an admin, elevation of privilege. The way to counter those, authentication, integrity, non-repudiation, which usually is through logging, some kind of monitoring and logging to verify that, users are doing what we think they're doing. Confidentiality, availability, and authorization or access control. So this is a way of finding threats, and it's a very easy and simple way, and a lot of people start there. I think it applies really best to data flows, but that's not all that you have maybe in your system. So there are other things to think about, and we'll talk about in a moment. There's also this game, Elevation of Privilege game, which basically another game that kind of helps you think about threat modeling using Stride. PASTA is another method which uses Stride and attacks and also uses risk analysis. Part of PASTA is that they include the actual simulated attack as part of the threat model. What I like to do is also look at the functional areas and ask questions accordingly. So ask questions about configuration management, sensitive data, cryptography, and so on. And so some of those kinds of questions I might ask is, who would be interested in this application and its data? Who are the threat agents? What are the goals, the assets? What are the methods that they're using? Are there any attack surfaces exposed? What are we missing? How's authentication handled? And when we say, okay, we've got authentication, ask specifically, what kind of authentication? What are you using for authentication? What are you using for access control? So it's not enough to just say, we've got a password. Well, okay, how's the password stored? How does it retrieved? How is it, those are kinds of questions you need to ask about the system. Are we sending data in the open and so on? One of the best questions I found, very effective, anything keeping you up at night? Is there anything in this system that you built that you would rather nobody ever know, or you forgot about and it's still out there, and I better go and fix it? So that's a great one to ask as well. So zipping through here, I want to take a look at a scenario, configuration management, back into our web diagram here. If I narrowed it down to where would I find configuration management problems, looking here, data files such as configuration files for a web app. Well, what's a problem with that? Well, it turns out that the reality is in that system, we have files. It's input into our system. Has anybody ever thought about, what if somebody changed the URL in that configuration file? What would happen? What if somebody was able to get at my configuration file with the connection string to a database and change that to another database? What would happen? So some of the security principles to be aware of: be reluctant to trust and assume that secrets are not safe. Knowing that, we can then ask the questions, how does this app use those configuration files? Is there any kind of validation on the data in those configuration files, or is it just an implied trust? And we're jumping ahead a little bit, but some of the possible controls and mitigation are, set permissions on those files. Don't just let anybody read those or write to them, but make sure that the process that's reading and writing those configuration files has, the right ACLs applied. Another thing is, validate the data that's coming from those files. Use testing, fuzz testing, to ensure input validation. So those are some things that you might find as a result of doing a threat model against your configuration management. So here we have some threats that have been identified. Let's talk about the mitigations and the risks. So there are a few options that you have once you've identified some threats. One is to just simply leave it as is. If you find that you have, let's say a SQL injection problem, now hopefully you don't leave it, but you could. You could say, I want to fix it later, or I have other things that I've found, I want to leave it as is. We already know it's there, it's low risk perhaps, let's leave it. You can remove it from the product. Ideally, you can remedy it with a technology countermeasure. The other is that you could also warn the user. Now, this is where you see the CSAs and so forth, where or agreements that we all come up and say, do you agree to this? And you scroll through and read it like everybody does and click OK. That may say, there are certain risks if you run this application. So the question is, what's the risk associated with things that we find? And that's where risk management comes in. You can apply the FAIR approach, which is a very drawn-out process. You can use, what I like is just a high, medium, low, which is essentially applying two factors: ease of exploitation and business impact. So ease of exploitation is, how easy is it for someone to be able to exploit our system? So if anonymous users can exploit it, more than likely this is a high risk. If someone has to know it very well, strong programming skills, then maybe your risk rating is low. If you're at the business impact, if all users are impacted, that's high. At low number, low. And then you combine those together, and now you have, let's say, for example, a medium risk threat. This is related to CSRF. Back to our configuration management. If we own the box, perhaps medium. If we're on the cloud, high. And the reason for that is maybe because we don't own it, and so on. So following up, document what you found, file bugs, verify bugs. If we missed anything, review it again. If there's anything new, review it again. And so then what you have ultimately is a living threat model. A living threat model. So finishing up here, secure design before new features. Drive your testing and other review activities and understand the bigger picture. I have some resources here, a lot of great books. Again, I'll make these slides available so you'll get these links and so on. And now we come to questions, and I just want to zip through because I'm running out of time, but I want to leave some time for questions. So, any questions on that whole process? We've got about 5-10 minutes there. Good question. So, as I mentioned, I know Brooke points out that the developers should do that, and I've had questions about that myself. And I think it depends on the organization. If you've never done this before, then more than likely the security group is going to be the ones who start it and start driving it and bringing it into the organization. But ultimately, I think what you want to try to do is get each of the groups start to own some of this. So, one way that I've seen, and I'm actually working with a client right now where they're starting from the security group and they're trying to help different teams get the skills and the training they need to do threat modeling so that more or less a way of duplicating the effort so that not just one person does this, but several do that. And so that, the small things, like for example, there's just some things that you should have in your application regardless, right? I should have proper authentication. I should have proper authorization. Those are things that should already be done before it ever gets to a group to say, let's ask those questions. So try to move that down into the basic questions. Can we get those answered? And then the bigger design questions continue to move forward up. So I think to answer your question, I think ultimately you want a lot of different groups to own their own threat model. But it may start at the security group and the security team to start, showing, hey, this is what we're doing and why and what it helps you do. And ultimately, it's helping you design better and secure code and secure systems. Good question. Anybody else? Those of you who mentioned that you've done some threat modeling, are you using any of the tools out of curiosity? Microsoft's tool, anybody? Okay. So, anyway, other questions? Yes? Sure. So the question is, where do you define and how do you define trust boundaries? And that's a good question because that can depend on a lot of things about your company and about your application. And what I see it as, again, typically the first place I start is where do we move from not being authenticated to being authenticated? Where do we go from not being authorized to now being authorized? But that can also vary depending on the process. It can depend on the user. So, that's where you have to, and also am I internal, am I external, so all those kinds of things may vary. But that's kind of my rule of thumb where I start. Where am I changing the state? It's more like a state issue. Where am I changing my state of security, being authorized or authenticated? Authenticated or authorized, and then moving from there. That's typically how I start, trying to understand trust boundaries. It could be user endpoints or it could be processes. And the reason I say that is because you want to be very careful. I don't know if any of you guys are doing microservices these days, which is the rage. Be careful about them because have you heard of the confused deputy problem? Is that familiar? Everybody heard of that? Essentially, let's say I have 2 or 3 microservices and I have a workflow. So one calls this one, which calls the third one. But what happens if I am somebody else who calls the second one, but I don't have the right authorization to do it, but I'm not checking it because simply I know that if I call this one and bypass this first one, I'll get it to do the things I want. And that second one, microservice, may not know and not realize who's calling it. All it knows is I call this third thing, which is a privileged operation. But because I'm not doing the correct checking, I don't know if it's this one calling me or this one calling me. But I'm going to do the right thing, which is call the privileged microservice. So the confused deputy problem is that second one is going to do what it thinks is the right thing. But if I don't have the correct trust boundaries defined, the correct authorization in place to do the right thing, the next thing that it calls, then I potentially have just introduced a security issue in my system, not understanding the importance of all the way through, not just users, but all the way through microservices calling other microservices. It really matters how the secure design is in place. Does that make sense? Yeah. You're welcome. And I see that. I mean, that's a common thing I keep seeing with microservices. When I get called in and somebody talks about API design, nobody's thinking about that enough yet, I think. Okay. Any other questions? Okay, great. Thank you.